Assalamualaikum. My name is Muhammad Ikram. So today, I, as the first presenter of this group, would like to talk about Kepler's first law. So basically, physicists such as Galileo and Copernicus states that all planets should travel along a circular path. But the data that they get just didn't fit. Instead, Kepler's, which is an assistant of astronomy Tycho Brahe, states that all planets should travel along in ellipse shape. If you didn't know, an ellipse is a shape like a flattened circle. So, Kepler's came out with his first law, which is Kepler's law of planetary motion. Kepler's law of planetary motion, or Kepler's first law, states that all planets move around the Sun in elliptical orbit as having the Sun at one focus. This means that all planets orbiting the Sun in a path described as an ellipse. If you still didn't understand of what I just said, you can stay tuned for the next video. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Rashidi Hakim and I am going to present about Kepler's second law. So basically, Kepler's second law means a line that connects a planet to the Sun sweeps out equal areas in equal time. So as we can see here, on the left side, the picture shows that the A1 and A2, they have the same time taken for a planet to orbit the Sun. So, in the conclusion, we can conclude that the A1 and A2 has the same area as the time taken is also the same. So that's all. Thank you.
Hello everyone, my name is Nabil Zakwan. So today I'm going to present to you about Kepler's third law. So Kepler's third law states that the square of orbital period of a planet is directly proportional to the cube of its radius of orbit. So how Johannes Kepler derived this formula? Johannes Kepler derived this formula from two basic knowledge that were learned in this topic. So first one is Newton's universal law of gravitation and the concept of circular motion or centripetal force. So as we know, when something is in orbit, centripetal force is caused by gravitational force. So from these two formulas, Johannes Kepler had derived a new formula or a new law, that is T squared is directly proportional to R cubed. So in this topic, in this law, just remember, the square of orbital period of a planet is directly proportional to the cube of its radius of orbit. So that's all from me. I hope you learned something. Thank you.
The Earth orbits the Sun with radius of 1.5 times 10 power of 11 meter and the orbital period of 1 year. Radius of orbit of planet Saturn is 1.43 times 10 power of 12 meter. What is the orbital period of Saturn?
Then, list up all the information given by the question. So T1 stands for the orbital period of Earth, that is 1 year, and R1 stands for the radius of orbit of Earth, that is 1.5 times 10 power of 11 meter. R2 stands for radius of orbit of planet Saturn, that is 1.43 times 10 power of 12. And T2 is what we need to find in this question, that is the orbital period of planet Saturn. By using Kepler's third law, we can get that T1 squared over T2 squared is equal to R1 cubed over R2 cubed. Next, just insert all the information given by the question that we had listed up in the beginning. So here the last step. Just do a simple algebra and do a simple calculation by using calculator, and then you will get the answer. So the answer is the orbital period of Saturn, T2, is 29.44 years.